Hey everyone, I thought I might go through a couple of the problems from our F3 quiz for you. I looked at the quizzes for those that have completed it, and I'm just going through the most commonly missed problems on each quiz. So watch this video just as a review of those problems and let me know if you have any other questions.
So here are some of the commonly missed problems on the F3 quiz for the non-honors students. The first question asks, in which situation are the forces balanced? Now, first thing that you should be thinking when you see something that says forces are balanced, remember that that means that there is no change in speed. So this could be a situation where you are either stationary, not moving, or you're moving at constant speed. So we're looking for situations where the object is either stationary or moving at a constant speed. So a car parked in a parking lot. Yes, forces are balanced because it's stationary. A car slows as it makes a turn. That cannot be a balanced force because it's slowing down. A car speeds up as it passes a truck. Not a balanced force. A car driving down a highway at 65 miles per hour. Now, since this doesn't say anything about changing that speed of 65 miles per hour, that is going to be a balanced force. So the correct answer here would have been A and D, which is that option there. 2 is a follow-up question to number 1. It says, why were the forces balanced in those situations in the prior question? So this is really getting at the cause of having balanced forces, so no change in speed. So why were the forces balanced? Well, the car was at rest, that could be true, or the car was moving at a constant speed. So B and C was the correct answer there. Okay, on number 3. Number 3 says an object is traveling at a constant speed. There are 2 equal forces acting on the object in opposite directions. So we're talking about a case where this dot represents the object and we have forces acting in opposite directions. So one is pushing to the right and another is pushing to the left. And it says that these are equal. So I'm going to add little dashes to denote that those are congruent or equally length forces. What will happen to the speed of the object? Just like we talked about in the previous questions, if 2 forces are acting in opposite directions, that's the case of balanced forces. Balanced forces mean that there is no change in speed. So if you have balanced forces acting on this car or any object, then the object will continue to travel at a constant speed. Correct answer there is C. 8 states, if the net force on an object is 0 newtons, remember that this N is read as a Newton, named after Isaac Newton, unit for force, describe the object's possible motion. 0 newtons means that we're adding together the forces acting on the object, and the direction of the force is a positive or a negative direction. So we could think about this one as being 5 newtons to the right, positive 5 newtons, and this one being negative 5 newtons because it's pointing to the left. The net force is equal to a negative 5 newtons, that one's going that way, plus the positive, just putting that in parentheses because if it was negative you'd need to include it, newtons. So when you have a negative 5 and a positive 5, that together becomes 0 newtons. So this again is the case of balanced forces. So in that case, we should see that there's no change in speed, just like before. So if the net force is 0, the object could be stationary. That's true. The object could be speeding up. That is not true. The object could be moving at a constant rate. Constant rate just means the same as constant speed. That could be true. The object could be slowing down. Not true, because that's a change in speed. So that means both A and C are possible. All right, number 9. An object is on a frictionless table. 3 people are pushing it with an equal force. This is really supposed to state that each person is pushing it with the same force. So let's draw our force diagram here. So a dot for the object. It says 2 people are on the right side of the object and one is on the left. So 2 people are on the right side, so let's put that over here. That's the right side. So they're going to be pushing to the left, actually. So there's a push from one of them, and there's a push from the other. Here's our left side. One person is on the left side, so they're pushing this direction. And that means that if I look at how the forces cancel out, we see that one of the forces pushing to the left cancels out with one of the forces pushing to the right. So at the end, I have just one force left over pushing to the left. So the correct answer on which direction is the overall net force, kind of the remaining force after we cancel everything else out, would be pushing to the left. Few more. So on number 10, we're referencing the previous question. So it says, choose the reasoning that fits best to explain the answer to the previous question. So let's make sure we can see both of those. One of the things that was stated in this problem is that it's on a frictionless table. So all of the forces that I drew on this diagram are coming from the people that are pushing. Okay, so let's see if what will fit the answer that I gave here. So with no friction, there must be a net force. I don't know if that's really true. I mean, there's always a net force. The net force just might be 0. So let's hold that one. All 3 forces are equal. Well, they aren't necessarily equal when we add them up to be a net force, so let's hold that one. Heavier objects are harder to move. That is true, but it's not necessarily in the context of the question. There is a greater force on one side. Yes, I would say that that is true. There's overall more force pushing to the left than pushing to the right. So that one I feel good about choosing. There are more forces on one side. Well, I would say that one actually is, well, let's be careful about this one. More forces, I could have more people pushing to the left, but with an overall weaker force than what is pushing to the right. So in terms of forces, we'd have to really quantify how large the forces are. So I would think that the best answer here is this one, but I could see how there might be an argument for choosing option A, B, C, D, E there. I think the best answer is D, but if you chose E and you were marked incorrect, then go ahead and let me know. That was a tricky question. All right, let's look at number 12. Is it possible for an object with balanced forces to be in motion? Well, as we've seen, that is true. You can have forces pushing and pulling in opposite directions. Let's say that this one would be like the force from the thrust of a car, its engine acting on the car, pushing it forward, and this would be a force from the friction that it's experiencing as its wheels roll along the ground, or it has some air resistance. So these are balanced, same length, and it would be moving at constant speed. So it could still have some velocity moving to the right. So yes, it is possible, and we have seen that. Reasoning that best supports my response to the previous question. Let's read through them. An object with balanced forces has 0 net force. Since there is no force, there is no motion. That's not true. It just means that the motion doesn't change. Although balanced forces mean 0 net force, the object does not have to be stationary. It could have an initial velocity. That is exactly the reasoning that we're looking for. So this thing was already moving. It just has balanced forces, just like when you maintain your speed on the highway or anywhere that you might be driving or on your bike. So I think that's probably going to be the best option. Let's look through the rest of them, though, just to make sure. An object with balanced forces can be in motion. Any force on an object is indicative of motion. Now, this is not necessarily true. And any force on an object is not necessarily indicative of motion. It could be that there are forces acting on an object and it's not moving yet. So you could have like a filing cabinet or something that somebody is pushing on, and it's still experiencing some friction. So this could have a force from the push of the person, and then also a force from the friction that it's experiencing, and those could be balanced. You have forces, but you have zero velocity. So forces are not necessarily indicative of motion. All right, option D, an object with balanced forces cannot be in motion because there is no acceleration. All right, so this is where if it was already moving, then it could be in motion. It's true that it has no acceleration because it's not changing its speed, but it could already have been in motion. So that one is not true. So B is our best answer there.